everyone. I'm Casey Wylie. It's a complete pleasure to be here presenting to you all today. And today, the topic of conversation is going to be how to configure gRPC-Web and how to actually configure that in Istio. So I'm going to go ahead and turn off my camera, and I'm going to go ahead and get into it at the end. We'll go ahead and ask some QA questions, and I'll be happy to field your answers at that point. So I'm Casey, I'm an engineer at Solo, and before we start, the process today is actually there is a link to a repository if you'd like to visit it and kind of follow along. And basically, at the end of this chat, I'm going to have a demo, and during this demo, I'm going to show you guys how to install Istio. For the sake of simplicity, we're going to install Istio using the demo profile. From there, we're going to actually go ahead and create the gateway. We're going to create a virtual service. And when we create this virtual service, we're going to be very careful to propagate the correct headers through the application so that you're able to use your gRPC streaming applications on the front end and consume gRPC streams from the back end. So let's get into it. As far as the chat agenda, I'm going to give you guys a very small background on gRPC. I know more than likely that most people are very familiar with it, but just in case there are some people that are less familiar with it, we're going to go into the problem statement with gRPC-Web and specifically using HTTP 2.0 in the browser. The next thing we're going to talk about is a solutioning demo overview, and I'm going to chat with you guys and everyone actually about an application that I built. The front end is a React app. It's actually using gRPC-Web. It's using the DevTools, and the backend is a normal Go application that's implementing the gRPC streaming. And next, we'll configure Istio. I have a nice script that's very, very simple, and it's very easy to actually stand Istio up in the cluster. It doesn't take very long, and I'm actually just going to do that live. So I'm going to go ahead and configure Istio live and deploy the applications live. After that, I'll go into a high-level recap. And then finally, I will finish with a demo in my Google Cloud Kubernetes environment. Okay, so gRPC streams and gRPC web. I'm going to give a very small background on gRPC stream types. So gRPC has 4 stream types. There's a unary RPC, and that's somewhat similar to REST in that you send one request and you get one response back. There is a client streaming RPC, and as far as the client streaming RPC, the client is going to send a stream of messages. There is a server streaming RPC, where it's the server that's sending the stream of messages, and that's actually what we're going to be implementing today and taking a look at. And then there is bidirectional streaming RPC, where both the server and the client are streaming messages. So why do we even need Istio? Why do we need Envoy, right? It seems like a lot of overhead to install Istio in the cluster, but granted, there is a lot of benefits that you get from using a service mesh. But really, why do you need it for gRPC web applications? Well, the answer to that is actually relatively simple. It's simply because HTTP 2 frames are inaccessible in the browser. And moreover, you cannot actually force an HTTP 2 connection from your browser to a backend. Browsers simply are not capable of that right now. So that's actually our problem statement. This is why we actually are going to use Istio to configure it. Now, if you are looking at gRPC-Web's website, they'll say you can use Envoy to configure gRPC, which is 100% correct. But the data plane of Istio, the engine of Istio, is actually Envoy. So we're going to look at actually how to use Envoy to leverage that configuration and to drive the configuration. So this, from a very high level, this is what a gRPC web application looks like. You have your gRPC web application that's running in the browser outside of the cluster. You have, in this case, you have Envoy, but in our case, we have the Istio ingress gateway. And then from there, the request path is going to go to the backend service that's requested. In this case, it's a gRPC streaming web application. So the gRPC web client will connect to Envoy, will connect to the backend services via Envoy. Envoy is going to facilitate that connection. As far as from the browser to the Envoy proxy, that's going to be HTTP 1 because that can't be forced. All right, so this is the very first kind of problem statement. Our question is, how might we leverage Istio to configure Envoy to facilitate the HTTP2 request to and from the backend to the front end? And I should probably go ahead and touch on the fact HTTP2, what does that mean? So that is a continuous connection, right? HTTP1, the connection opens and closed. In HTTP2, the connections stay opened. If you want an example of this, let's start thinking about things like WebSockets, gRPC streams. The connection stays open, and it's a much more efficient protocol in terms of transferring and sending data. So if we're actually looking on gRPC-Web's website, we can actually see that they have specified us with an Envoy config. So this is actually a concatenated version of the Envoy config. But if you know Envoy is actually somewhat simple, right? It actually shows the requests and the paths. We can see we have a prefix here. We can see what our target endpoint is. In this case, it's a greeter service. In my case, it's called a backend service. But the really important parts here are gRPC-Web's website, their documentation gives us the exact headers that need to be passed to Envoy in order for it to facilitate this connection. And those headers are the allow headers. You have to have the keep alive, the cache control. All of these allow headers are going to be necessary. You're going to want a max age, and then you're going to want also the expose header section. So we're going to be basically simply translating this Envoy config to an Istio config, which will in turn translate it again to an Envoy config because Envoy is the data plane for Istio. So this is the POC solutioning overview. If I was just talking, it would be, at least the way I learn is a hands-on way. So that's why I wanted to give you all something that you can play with yourselves so you can decide for yourselves if this is a way that would satisfy your own use cases. And this is a very tried demo. I haven't got it to fail yet, but most likely my first failure will be during this live demo. But high level overview, the web application is going to send through HTTP to the Istio ingress gateway. The Istio ingress gateway is going to handle the facilitation to the backend, and the backend is going to be streaming continuously back to the front end. Okay, so this is just a little tip, and this is something that I found much easier when you're creating these applications that you are using, gRPC streams, due to the fact that you have a protobuf. So if you're using a monolithic application, which is an application that has many or a repository that has many applications inside of it, it makes the generating of the protobufs much easier. And I actually have in the code how you can just use this from a shell script and it will generate the code into the React app from the gRPC streaming backend. So the goal for this is to have the most simple use case possible. I don't want anyone to get lost by a complicated protobuf file. This is a very simple protobuf. Basically, the request, what the client is going to request from the server is they're going to send a string that's the user agent, right? And if you know the user agent, it's like Chrome, things like that, your user agent. But the response is going to be a Boolean value. The second is going to be a timestamp. The third is going to be that same user agent that the client sends into the server. It's going to be echoed back. And the fourth is going to be a count variable that will continuously increase over time. And we can see our service numbers. We have just one function, get numbers. It takes in this numbers request, which is a user agent, and it returns a stream of number responses. So this response is just going to keep streaming. And The way I programmed it for simplicity is actually an infinite for loop in Go. So speaking of Go, right? So here is our backend code. Our backend code for the Golang application is, it's an infinite for loop. This variable I is declared out of scope outside of main. So it's initialized with this value of 0. And every single iteration of this for loop is going to consistently increase. We're going to be sending an API number response, exactly like we were talking about in the proto. Our Boolean true value is basically if it's divisible by 2, if there is no remainder left over from 2, it's going to be a 0. So it's going to be true. If it's an odd number, it's going to be false. We're going to get a timestamp. We're getting the user agent from the request, and then we're returning an overall count. And then we simply send that back into the stream. So in Kubernetes, I want to go ahead and set everyone up for success here. This is a huge gotcha, and this is one thing that got me initially. But when you have your Kubernetes service definition for your backend, and my backend is simply called backend, and my frontend is called frontend, also for simplicity, which is not a good convention, obviously. But for this demo, the port name is gRPC-Web. It's not gRPC. This is important, and this is in the docs. So when everyone's configuring this on your own, make sure you name the port gRPC-Web, as it will be communicating with gRPC-Web frontend service. Now, the React application or the frontend application. So here, I'm going to go ahead and throw you guys some ideas about what to use in your own environments, but let's go ahead and explain it first. Our client is the numbers client. More importantly than that, and this is just a little morsel of information, when you're using Istio or when you're using Kubernetes, you usually say service.namespace.svc.cluster.local, right? That's how services communicate with one another inside of the cluster. Only that this is a React application. It actually sits outside of the cluster. And this React application that's sitting on the client's browsers is going to have to communicate back through the cluster. Therefore, we cannot call our backend service backend.default.svc.cluster.local, right? Because our request is going to have to go through the gateway. That's the only way. So, and we all know it's actually very simple to attach a cert onto the Istio ingress gateway with the HTTP port. So the reason that we have defined this numbers client like this is we're using the window.location.protocol, which is going to be HTTPS if you're communicating over the HTTP port, and then the gateway URL. This is going to be kind of simplifying your app and going ahead and kind of setting you up for success for day 2 operations as soon as you're locking down and securing your applications. The next part that's rather interesting, at least in my opinion, is the enabling DevTools. Enabling DevTools, this is actually gives you a lot of good information inside of your web browser in the Chrome DevTools. It's only 2 lines. Once you install the gRPC web package, you can already use it. So this is going to show you information about your requests that are coming in and leaving. Other than that, we have this get number stream. We declare the requests. We specify the user agent that we're going to send to the backend, and then we go ahead and initialize our stream. Once the data starts coming in, our React app has a state. This state basically is going to display only one component to the user. The component is going to display the true or false Boolean value, whether the number is even or odd, the timestamp in which the request was originated in the backend, the user agent that we gave to the backend, and then the total count aggregated of all the requests that have hit our application. And one more thing on the front end. This front end is actually very, very basic, right? It's very basic. It has a Protobuf, and it just has basically one component. And that component is just for you to see how the gRPC web works. And here I went ahead and kind of just circling back on what I said about having a monolithic repository. If you have a monolithic repository, you can run both of these 2 commands to compile your Protobuf from the backend, from the Golang app. And this will also compile the exact same Protobuf app. And in my personal front end, I have the Protobuf in an API folder. And actually, it's just a standard that I typically use. But and I didn't even come up with this. This is like, I think this is pretty much an industry standard, but I'm not sure. I've seen this used a lot. But I have my Protobuf in the API folder. So this, as long as your front end and back end apps lexically are in the same hierarchy and have the same parent folder, you can use this command, and it's going to generate the Protobuf file in the API folder from the front end, as well as the API folder for the back end. And then the biggest gotcha of all, most likely, in my opinion, is when you generate the Protobuf file, you have to, and for the React app as well, go ahead and go off cue here. These two files that are generated for you, the number.protobuf and the number gRPC-Web protobuf, both of these files need this ESLint disable, both of them. By default, only one file will have it, but make sure you have this line on both of them or you'll have compilation errors. Or really interpretation errors in your front end as your front end's interpreting your JavaScript. Okay. Now let's get into the Istio configuration. So we were looking at the Istio configuration earlier, and now our really only job is to just translate that into Envoy configuration. I said it was easy, and the reason I said it's easy is because they basically have the exact same names, the Istio configuration, the Envoy configuration. So this Istio configuration is an Istio virtual service. And this is a brief snippet of it. The full virtual service is in the repository. The repository is public. You guys can check it out, play with it, spin up your own clusters. Let me know how it works. But this is actually the virtual service. As you all can see, we have the exact same allow methods. We have the exact same allow headers. We have the exact same expose headers, just because that's what gRPC-Web taught us to do in the docs. So at this point, it was just simply translating it to the virtual service. So here is the demo, the little POC. It's very simple, but basically just 4 steps. We're going to install Istio using the demo profile. I say this is only for demo purposes. The reason I say this is because nowadays Istio says you shouldn't install everything in the same namespace. Like you should have your ingresses in their own appropriate namespaces. Actually, the latest actually says that you should have, correct me if I'm wrong, but I think it's actually the East-West Gateway and the North-South Gateway in different namespaces. But anyway, it's a demo app. Everything's going to be in the Istio system namespace. Then we are going to deploy the backend. Then we're going to deploy the front end. And then we're going to create the Istio configuration necessary. And the Istio configuration is we're going to install like the world's simplest gateway. It's like the gateway for the pet store app, if you guys have ever used that app. Then we're going to create our virtual service and our destination rules for the backend and front end. Okay, so short and sweet. That's it for my demo. So while this is happening, so in terms of the repository itself, this is public on GitHub. I highly encourage you guys to interact with it, play with it, especially if you have any questions. But what you can do is we have our simple backend service. It's just our Go service. It has the exact same things that I was showing you guys in the slide. And then we have and here's our API. Here's our proto file. And here's our front end, our API folder. And then this is our actual front end application. This is the only component that we're actually using. This is our only smart component because it actually gets the data. Here's how we actually enable DevTools. So this is it. Next thing I want to kind of point out briefly is we have our backend deployment, our service account. We're not even using the service account right now. remember, our service is labeled gRPC-Web. We have our front end. Our front end is deployed in the normal way. Other than this isn't deployed behind Nginx or any way that you would normally deploy your front end for production. This is actually just, I'm using npm run for this. So I deployed it in a very simple way. Here's our Docker file if you're interested in seeing that. All right, so here we go. I forgot to delete everything before, but I'm pretty sure this is just gonna work out just fine. All right. So very first part, I'm showing you guys how to create a cluster in GKE. You don't have to use GKE, but the reason I think you might want to use GKE, and it's actually not a huge difference, but I have the value for the React app gateway URL, and I'm actually getting the Istio ingress gateway's ports. And as we can see that right here, this Istio ingress gateway port. And basically I'm saying kubectl get Istio ingress gateway, and then I'm pulling out the IP. If this was AWS, this very last line, if I'm not mistaken, would be host name and not IP address. But if you just look at the service definition, you'll be able to find the ingress gateways. Very, very easy, I think. Okay, so the first part is we're going to go ahead and install Istio. What I'm doing here is I'm changing to a directory that's outside of our paths. I'm downloading Istio. I'm installing it via the Istio kettle. I'm installing the add-ons. I'm labeling the default namespace as Istio injection. The reason we're doing that is for the Istio sidecars. See something really fast. And I will go ahead and actually open up the floor to a question or two if anyone has a question right now.
So Stanley Sean says, one of the maintainer of gRPC-Web here, I vaguely remember the SLIN disable issue. We should probably dig into that again.
Yes, yes. That is that's a good point. Oh yeah, absolutely. Yeah, that totally stumped me. Yeah, thanks for bringing it up. But yeah, absolutely. Yeah.
Casey, I had a question.
Hey, sure.
Yeah, thanks for the talk so far and the demo code. I think it will be really useful. So you mentioned that between the browser and the Istio proxy, it's HTTP/*, I saw you mentioned. So what exactly is the protocol there? Because I mean, modern day browsers, if you, I believe, if you just talk over HTTPS, it will default to a HTTP sort of connection at least. So yeah, can you please explain that a bit more?
Sure. So the root of the problem is actually that the browser can't interpret the HTTP2 frames, right? And this is actually in active development. There is, I'm going to butcher this name, but I think it's called, this is not what it's called, but it's something like JavaScript scripts. No, it's like something streams. But with this streams, you're actually going to be able to force HTTP2 in the browser. Currently, you can't force it. And I mean, you can probably try this on your own, and sometimes you can get it to work if you have like a local environment. And oddly enough, I've had it working with TLS at times when I actually give a cert and a private key to my application. Sometimes it works, but it's just not consistent. So that's why, yeah.
Right. So just to make sure I understand this correctly, so in say when you're using just like a command line gRPC client, it understands the streams and all that. So you're saying that the browser currently do not understand that like properly?
Yes. Yeah, that's exactly what I'm saying. I'm saying that the browsers are going to be unable to actually interpret the frames from HTTP2. But yes, that's exactly right. But if you're using gRPC curl, you're going to have zero problems at all.
Okay, thank you.
Yep, no problem. Any other questions?
Yeah, I'll go probably next. Yeah, thanks for the presentation. It's a very nice intro to gRPC-Web and how to get it working. Have you also tried can Envoy also be used for like a REST API gateway for those who want to actually also have REST clients and do the translation in Envoy with the same setup, or?
Yeah, great question. Great question, Srini. Yeah, Envoy is highly dynamic and super highly configurable. Envoy works great with REST applications. And in your Istio gateway, for instance, to kind of revisit that question, if we're looking at our Istio ingress gateway or our actual gateway CRD, we can see right here we have one port defined, which is an HTTP port. We could have an HTTPS port right here, and we could also have a gRPC port. But you don't need Envoy. I'm sorry, you don't need Istio at all for that. Envoy is perfectly capable of handling gRPC connections, and it is actually very good at it and has a very high throughput.
All right, thank you.
No problem.
Also, Fidel Ruiz says it could be easier to use gRPC gateway.
In Istio, I'm guessing you're talking about an Istio, right? Fidel?
It doesn't says, but I guess.
Sorry. Hello, everyone. Sorry, I jumped in there. Essentially, I'm saying that for those layers, in this case, is because we want to have gRPC communication or binary communication between the front end and the backend directly. With the gRPC gateway, you will have just the part of the REST API, and it actually generate those, that extra transport layer in there. So, yeah.
Great, cool, good to know. Great to know. Thank you, Fidel. So I am ashamed to say I was bragging how this demo never broke, but then it looked like the last time I was actually using the demo, some of the namespaces didn't get deleted. So I guess that's how it works when you're presenting live. My fault about that. Sorry, everyone.
Don't worry. Okay, so does anybody else have any question? If not, all good. Okay. Yeah, so please, everyone, if you could complete the survey, that would be great. And Casey, thank you so much.
Yeah.
I guess everyone enjoyed your talk a lot. So thank you for sharing all of this with everyone. And I hope we could have another meetup anytime soon.
Absolutely, I agree. Everyone, thank everyone so much for having me. It's been a pleasure chatting with you guys today. With you all.
One more
Thank
thing,
you.
Casey,
Yeah.
you have posted a URL with a repository. Is that the URL with the sample code that you showed?
Yeah, I will
Okay.
paste it back into the chat right now.
Yeah, in case somebody missed it that joined in later. So that's the repo with the code that you showed. And when running it locally, we shouldn't have an issue with that namespace, right? Because we're doing it on a new environment.
Yeah, that's 100% my fault. I was kind of multitasking during the day, debugging some Istio, and it bit me.
Don't
It was a bad
worry.
mistake.
No
Don't
worries.
worry.
Also, Xiaofeng is asking if there's someone from Google in this meeting. But besides that, I would like to invite everyone, if anyone is interested on presenting a demo, just as Casey just did, and it was great. Thank you. If anyone wants to present a demo, please do not hesitate to contact us. And yeah, because we are all the time trying to find a speaker. Okay, so thank you again, everyone, for joining us. And thank you. Thank you for being here. Thank you, Casey.
We should
Yeah,
continue with the questions here. Shafen has some questions, right?
Yeah, so it was unrelated to the presentation,
perfect.
but
Okay.
even so we can,
Yeah.
I mean, it's a community meeting, so we
So
can just
this
have
is
an
not
open discussion.
related to the presentation, but it's like in general question regarding the binary log in the gRPC service. We're trying to use this to build a debugging platform, but it's just very hard to find any related information regarding to the binary logging feature from the gRPC servers. So we're wondering, what we can do. How can we get some help on this topic?
You ended up having sent an email to gRPC-Web, to gRPC.io mailing list. Is that right?
I have some question posted there, but nobody replied.
It's in the queue. I think C won't be what you're hoping for, but Go will be pretty easy, and then Java, there's some ways to mostly make it doing.
So how about .NET? So we're primarily using C#.
That was one of the open questions. I think the .NET stack, I mean, we're talking about the one that's not based off of C core. I expect it doesn't have any binary logging, just if I was going to assume something, but it needed to be investigated. So.
Okay. So I just to clarify, like, is C# like the core part of the gRPC infrastructure, or it's part of the .NET?
So can you say that again?
So I think we have, like, my understanding is, like, regarding gRPC, we have very basic support for C++, Python, those parts, right? And on top of that, we have Go and the .NET. So is C# part of the primary gRPC infrastructure as part of, or it's part of .NET?
So it's sort of both. So the classic C# was built off of C core.
Okay.
It supports the older .NET platforms.
Okay.
There's a newer implementation built off of .NET Core, and the .NET people will say that I'm saying the wrong words, but I think the gist will be about right. And so for the newer platforms, you would use that .NET implementation. And that's the one that would be encouraged to use going forward. The C# one is still living. It's still working and things like that. But that aligns better with the C# and .NET communities.
Okay, just to clarify, so you mentioned, in Go or Python or C++, the binary logging is already there, but not in .NET yet.
So in C++, the language is built off of C. So I think that'd be Python and C++. I think that there is not much in the way of binary logging.
Oh, not much?
Yeah. There might be some skeletons of something, but I don't think that there's anything quite enough.
Because I searched really hard trying to find some source code, but I can't. So it's not implemented yet. But the proposal was kind of like approved back in 2018. Right?
Yes. The Go implementation should be very easy for you to find. The Java implementation is also available. The Go implementation, though, whenever you look at it, you were wanting to filter some of the binary logging entries that you were getting, some of the log entries. Go will make that very easy. There's an open question in Java. I think you might need to do a cast in order to get similar behavior in Java.
Okay, so
because
Go
it's a
and
bit more
Java,
opaque.
it's already there, but not for C#. So only Go and Java. Is that correct?
Yeah, Go and Java are the ones that are definitely there. The .NET being the newer implementation, it may be there, but I'm uncertain. The C-based languages, we're pretty certain it's not there. But there is going to be a reply to your email on gRPC.io.
That would be great, because we primarily use .NET. Next to that is actually Go, and we have a little bit of Java. So if that's kind of like support, that would be great. But how can we double check if the binary log supporting is in the .NET?
Which of the two are you interested in? Are you the new implementation or the older one?
The new one.
Okay. We'll have to connect separately outside of this meeting.
Oh, So if this is not implemented, it's possible we can actually help contribute back to the community. We can find some engineer to work on it. It's just we don't know how to start.
I gotcha. There's also some different, having a conversation specifically with the .NET folks will probably need to happen. There's also some .NET potential options going down those lines. But
Okay.
yes, we'll
Okay, so good. This is actually going to be very important. So we kind of want to build something on top of OpenTelemetry. That's another effort from Google. Previously, I was working at Google, so I'm actually aware of this kind of effort. But okay, anyway, so please reply the email at your earliest convenience, and we can see, whether we can actually help contribute to some of the implementation there. Okay, great. Thank you.
Okay, it looks like Casey already left. If any of you still have questions left for Casey, we'll be happy to forward them to him. And if not, we hope to see you on the next month's talk. And as Teysa mentioned, if any of you would like to present or share what you're doing, please send an email to teysa@sg.com.mx or to Maria, or post it in the channels. Thank you so much.
Thank you, everyone.
Thank you.
Bye.
Bye.
Bye.